Now I discuss the different operation mode of the triad. There are 4 operation mode of the triad. The first operation mode is we consider MT2 is positive and gate is positive. So we connect a battery between MT1 and gate. The positive terminal of the battery is connected to gate and negative terminal of the battery is connected to MT1. So current follow through the circuit is MT1 to gate, and the current inject charge carrier from P2 to N2. So P2 N2 junction is gate forward bias, and again MT2 is positive with respect to MT1. So P1 layer gate activated, and P1 N1 junction gate forward bias, N1 P2 junction gate reverse bias. So the current follow through this track is P1 N1 P2 and N2. This is the first operation mode of track. Now the second operation mode, we consider MT2 is positive and gate is negative. So we connect on voltage source battery across MT1 and gate, and negative terminal of the battery is connected to gate and positive terminal of the battery is connected to MT1. So the current follow through this circuit is gate to MT1, and current charge carrier inject P2 to N4. So P2 N4 layer gate forward bias, and MT2 is positive with respect to MT1. So P1 layer gate activated, and P1 N1 junction gate forward bias, N1 P2 junction gate reverse bias, and the current followed through this track is P1, N1, P2 and N4. This is the second operation mode of the track. In the third mode of the operation, we consider MT2 is negative and gate is negative. So we connect on battery across gate and MT1. Negative terminal of the battery is connected to gate, and positive terminal of the battery is connected to MT1. So current followed through this gate circuit is a gate to MT1, and current inject the charge carrier from P2 to N4, and again MT2 is negative with respect to MT1. So P1 layer gate activated, and P2 layer gate activated, and P2 N1 junction gate forward bias, N1 P1 junction gate reverse bias, and again P1 N3 junction gate forward bias. So current followed through this track is P2 N1 P1 and N3. This is the third operation of track. Now the fourth and last operation mode, we consider MT2 is negative and gate is positive. So again we connect a battery across gate and MT1. Positive terminal of the battery is connected to gate, and negative terminal of the battery connected to MT1. So the current followed through this gate circuit is MT1 to gate, and current inject charge carrier from P2 to N2, and again MT2 is negative with respect to MT1. So P2 layer gate activated, and P2 N1 junction gate forward bias, N1 P1 junction gate reverse bias, and again P1 N3 junction gate forward bias. So current followed through this track is P2 N1 P1 and N3. This is the last operation mode of the track. Now I discuss the characteristics of the track. The x-axis, we consider the voltage across the track, and y-axis consider the current follow through the track. So when we applied some voltage, some current followed through the track. This current is called the leakage current, and up to breakover voltage, the track is not conducted. This zone is called the blocking forward mode, and after breakover voltage, the track is conducted and current follow through the track, and this stage is called the on state condition. And 0 to breakover voltage, this state is called the forward blocking mode state. Similarly, if we applied some gate current in the track, so we see that the breakover voltage is reduced. Here see that different gate current. First is Ig1 equals to 0, means that we applied no gate current. So this voltage is called the forward breakover voltage, and after increasing gate current, we see that breakover voltage is get reduced. Here Ig3 is greater than Ig2 greater than Ig1. Similarly, we see that the third quadrant characteristics is reverse of the first quadrant characteristics. In this case, the MT2 is negative with respect to MT1 terminal, and first quadrant case is MT2 is positive with respect to MT1 terminal. So in characteristics curve, we see that the operation mode of 1 and operation mode of 3. Now I discuss about the experimental data level. This is the circuit diagram of the experiment. This is the track. One voltmeter connect across the track to measure the voltage across the track. An ammeter connect in series with the track to measure the how many current follow through this track. And this is the AC supply. AC supply. On this is DC gate source, an ammeter connecting series with the gate circuit of the track. Now when we applied the sub voltage, the track first time the track is gate non-conducting mode. After breakover voltage, the track is gate conducting, then current follow through this circuit, and below conducting mode the voltmeter voltage and supply voltage are get same. After conducting mode, voltmeter voltage reduced to near to 0, because at conducting mode the voltage drop across the track is shown in this voltmeter. Now when we applied some small amount of current through the gate, the breakover voltage of the track is get reduced. In our data table, we take two gate current and perform this experiment. So gate current 1, we set the gate current 2.95 milliampere, and we applied the voltage 0, current 0, voltage 10, current 0.1, current voltage 20, current 0.1. This current is the leakage current of the track. After 40 volt, we see that the track is get conducting and the voltage reduced to 0.8, and current of the ammeter goes to 15, 20, 25, 30, etc., etc. So this 40 volt is called the breakover voltage of the track at gate current 2.95 milliampere. And the second data table, we set the gate current 3.1 milliampere, and again we perform this experiment. We set the voltage, we applied the voltage 0, 10, 20, and this is the leakage current. After 30, we see that the track is gate conducting and current will increase 15, 20, 25, 30, 35, etc. So in gate current 3.1, the breakover voltage is 30 volt. So when we increase the gate current, the breakover voltage is reduced. So from this data, we plot the characteristics curve of this experiment. So x-axis we plotted the voltage across the track, and y-axis is current follow through the track. The first data we plotted uh, voltage is 0, 10, 20, 30, etc., etc., and 40 is the breakover voltage. After that the current is increased. This state is called the on state of the track. And second reading, we see that the 30 volt is the breakover voltage, so the breakover voltage reduced to 30, and then again the conduct of the track and current follow through the on state condition.